This video is going to kind of give you an introduction to the freehand sketching of multi-views of these objects, and this is what you'll be doing for your in-class assignments for the next few weeks. Here in the textbook, we're starting exercise 2.1 on page 59, and if you look at these, you've got an isometric drawings. The arrowhead tells you the front view. Most of the time, not always, but most of the time, this left face is going to be the front view of our object. It's broken down into grids that correspond to your drawing. The main warning about the sizes of the grids is when you have an oblique surface, even though it shows 3 grids coming down, those grids are longer than these grids. Okay, they match up here, so you can't just count 3 grids down and then try to angle 3 grids. It's not going to work. You have to count horizontally and vertically to determine the start and the stop point of an angled line when it's in isometric. Another thing that the book tells you in the little gray box right over here, if it appears symmetrical, assume that it is symmetrical. Okay, like this one here. If we count the blocks, we got 3 to the left of the arc, 3 to the right of the arc, 4 to the left of the notch, 4 to the left of the notch. Okay, symmetrical. This one, however, is not, because this sloped surface here is 4 grids up, whereas this sloped surface is only 3 squares up. Okay, so do some counting and some investigation, and then if it appears symmetrical, it is. If a hole appears to go all the way through, assume that it goes all the way through. Okay, this one is obvious. We've got a front surface and a rear surface. These are not so obvious, but assume that they go all the way through. This one goes through. The one here, this is what we would call a counter bore, in which we have a larger diameter hole that has a depth, and then a smaller diameter hole that goes the rest of the way through. If you will flip your book over, page 229, and let me zoom down on that a little bit, okay? Here we have a counter bore hole with the dimensionings here, and the way the dimensions are is the first diameter is the smaller hole that goes all the way through. The second has a counter bore symbol with a diameter, and then a depth for the counter bore. Okay, so this is in plan view looking straight into the hole. If we go to the side view, in this case the front view, in which we see the profile of it, here's our counter bore. It has a diameter of 1 and a depth of 0.25. And then the 0.75 hole goes all the way through. I'm showing you this so you'll understand how the hidden lines should appear. Okay, these hidden lines here will join because those surfaces join in the object. And you got your hidden lines that come down. These do not go all the way up, and these do not go all the way down. So look at the example on page 229 right here for drawing the counter bore. Now don't be confused, because this one is a countersink in which the sides of the hole are angled so that a flathead screw can go into that hole or something along those lines. Okay, so let's go back over here and look. I'll walk you through this one to kind of get you started. Here's your paper that you'll be using, and there's copies of it in the lab. You don't have to tear it out of your book, but it's giving you the starting points for your views. So here's the lower left corner of my front view, upper left corner of my top view, lower right corner of my right side view, and then a 45-degree projection line. Okay, now I would recommend start with a light pencil and then come back in and darken afterwards. But if we look at this, and basically you're going to count your squares. And that comes in 3, 4, 5, 6, 7, 8, 9, and then goes up. It goes up 2, over 1, up 1, back 3, up 3, over 4, back down to there. Okay, so I just roughed in my front view. If I can take these things and project them over for my side view. So I know I've got a height up here. If I'm looking in this direction for the side view. And you got to remember, when you're looking straight at the object, all you're seeing are these three planes, and they're stacked on top of each other. You know, if you imagine turning it and looking straight at it. So that's 4 wide. I know this height comes clear, so I've got a surface right here, so I know I've got a line that comes across. And then I've got this surface, which has a notch taken out of the top of it. Okay, so there's my side view. If I use my projection lines, and we'll do this sometimes in CAD, and we'll do it in hand drawings later in the semester when you get to using the drawing boards, you just take this and you kind of project up, and then you project across. And so that tells me the edge of my top view is here. So that's the front surface of my top view. Well, you know, if I'm counting, I can count squares, yeah. But anytime you have to measure in a drawing, you're introducing a greater possibility of error. So if you measure it once and you get it right here, and then you can project, it makes it more accurate. And in AutoCAD, it actually makes your drawing quicker, faster. So project up, and then I know that comes across. From here, I can project up my front view, and that gives me the extent of that. I know I have an object line here. I have another one here. And then I have these for the notch here that projects up 1 square. I project it across, and it's in here. Okay. Now I have not dealt with my hidden lines yet. So let me go ahead and darken. Okay, so that's all my object lines. I got them darkened in. Now I've got, excuse me, I've got this little notch right here that when I look at it from the front view, I'll have a hidden line indicating this surface plane. So in my front view, I'm going to have that coming across right here. And hidden lines should be about 1/8 of an inch long with about a 1/16 inch dash. So, you know, about half a square in our case here, maybe a little bit more than half a square. In my side view, okay, well, top view, I'm going to have a hidden line here because I've got this surface plane that in my top view I can't see the edge of that, but it is there, so I want to indicate that. Okay, and then in my side view, I've got this surface plane, which does not appear in my right side view, so I need to project that across and put that one in. Okay, and so now there's the first object finished up. Okay, now then let's look at, I'm not going to draw all of them for you, but if we look back here at the second one has holes in it. So where we see the circle, we would put a center mark, a little plus in the center, and then center lines that come out. Okay. Where a hole goes through, we do hidden lines for the edges of the hole, and then a center line, no plus in the center, just a line, a dash, and then a line coming out. Okay. Same way in the side view, this one gets a little confusing because we've got the hidden lines for the hole, and we've got a hidden line for this this change in plane here and this change in plane, which that one is under an object line. So we would draw the object line and not show the hidden line. This hidden line would be this edge, and then these two would be for the hole. Okay. You should be able to work your way through all of these. It's a little bit of a practice in sketching how to convey your thoughts on an object. But a big part of it is about how to visualize the object and then transfer from a 3D to a 2D sketch. Okay. If you have questions or problems, ask me or the lab tutors while you're in the lab working on this.